You're reading the Iliad, I can tell. There's, oh, I can. You will be Greekified and rarefied. Okay, people, you guys got your IDs out there. Benjamin, you've got your ID. At the bottom, double angle formula. At the bottom, double angle formula. Which one do you want to use? Madison, which one do you want to use? Exactly. Why? That was a good choice. Why did you choose that, Madison? There's already a sin x. There's already a sin x, so that makes complete sense. So then you get, can I cancel the 2's out? Would you be okay with that? If I cancel this one and this one? Yeah. So you get minus sin x plus 1 minus 2 sine squared x equals 0. No, it's like this, right? You have 2x plus 2 times a plus b equals 0. And you cancel this 2 and this 2? Because there's a 0 on the other side. Remember, canceling is dividing by 2. Okay, you're dividing out by 2. Okay, you guys with me on that? Now what do you want to do? Hello? Now what do you want to do? Henry? Foil? What's the F? The wrong F. You got the wrong F. What I would suggest is I would move this guy over like that, because now this is beginning to look like 2x squared plus x minus 1, which is called what's that called? Exactly right. It's a quadratic equation. Except it's not in x, in sin x. Okay, big deal. We've done this in pre-calc, by the way. So what I'm doing right now is all pre-calc. Okay, we've done this before. So guys need to, yes, Henry, which was the F now? Which was the factor F? Not the foil F, but the factor F. What do you get? Okay, is everybody with me on this? Yes? And then if you want to solve this, what do you do? Yeah, friends table would be next, but before that, 0 product property. Set this to 0, you get sin x equals 1/2. And if you set the other one, you get sin x equals, and now you're friends, okay? Now you're friends. So who are your friends here? Oh, you're looking at Facebook. They're not on there, I don't think. Pi over 6. Q1 and then Q4. Yeah. Can't be 5 pi over 6 for 1/2. Oh, yes, you know, you're right. Q2. Sorry, my bad. Q2, not Q4. Right? All students take calculus. Second quadrant sign is positive. So there'll be 5 pi over 6. Thank you, Stephanie. Yeah? And how about sin x equals -1? Wow, your friends are getting fewer and fewer as time goes on. 9 is 1. Madison, 3 pi over 2. No, it's not. It's like me calling you king. How would you like that? Remember I did that the first year? Yeah, you remember that there was that fob sitting there? King, remember him? Yeah, and you guys had almost similar names, and he was king. Except he's fob and you're not. Okay, you guys. You mean you look more kingly than he did? Okay, Henry, you had a conceited man. The guy's a player, isn't he? Isn't he really conceited, man? Yeah, he is. Okay, can I move on to 2.5 then? Okay, 2.5. You guys done with the chain rule? You've had enough of being chained? Chain rule is really important. Okay, 2.5, be implicit differentiation. So where are we? Okay. So there are really two sets of equations here. There's this set, and there is this set. And I want you to answer this question here. Got it? Answer that question? Oh, okay. Well, I'll pause here to turn this on.
Oh, just kidding. Wait, no, I got it. It's because the implicit ones have two variables behind the equal sign.
The implicit ones?
As in like x, y equals 1 as opposed to y equals x.
Okay. You're kind of getting there. Can you state it in a more concise and more beautiful way?
Sorry.
Jonathan? Hang on, Jonathan's got it. Jonathan. Hang on. Oh, let's not even talk about calculus right now. Let's not even talk about calculus. Henry.
Is it like for implicit one? Is it like it always like multiplies into like a constant thing?
Is it?
Something beautifully stated, but precisely it's not quite there yet, Kingsley. It's not quite a Kingsley statement. Yes.
Wait, so
The ones at the top are equations.
Well, this is an equation.
Okay, the ones at the top are functions of y.
Okay, state it nicely. Even yeah, you're very close now.
Wait.
Very close. Not functions of y, but
Functions are functions of y.
No, that's not.
no, they're functions of x. But Henry, you guys want to duke this outside? Yes, you want to take him outside and kind of thrash him?
Wait, was I close? Like.
No, S was very close. S was very close. Yeah, Layla.
Yeah.
These y's and x's. Why are you confusing the issue? Okay, so Joe. Okay, listen up. Sorry? I don't know. Yeah, Henry, one more chance.
Okay, so for explicit, it's always equal to y, and for implicit, implicit, it's equal to like whatever.
For explicit functions, the y variable is on its own. Period. Period. It's on its own. Right? That's why it's explicitly a function of x. Right? Y is explicitly a function of x. Okay? Y is by itself. Y is by itself. Okay? Alright, so what it means is that we need to learn how to differentiate functions like these. Because we've been doing this for a long time. You know, we did the product rule, the quotient rule, the sum and difference, the chain rule, and rule after rule after rule. Okay? So we did it all on y equals stuff. Okay? So now we got to start working with implicit functions. That doesn't mean that you forget all those other rules. They stay there. They stay there. Okay? And so here's the bottom line of how to differentiate implicitly. So get this down and I'll explain this to you, okay? Explain what this is all saying. Okay, so this is the rule. This is the rule. Okay, so what's it saying? You know that when you're differentiating, you're always saying something like d by dx of some stuff, right? When someone says differentiate, oh, that means d by dx, typically, right? X, it doesn't always have to be the variable, but by 90% of the time it's x, okay? Well, then it's, what was that? What was that? Oh. So,
What did you think I said?
I thought you said it's something else. No? Okay, so, you guys with me on this? Okay, so what this implicit rule is telling you, okay, what the implicit rule is telling you, Sujal, don't worry about that nonsense that's going on here. The excitement is out here. Okay, all right? The implicit rule is saying this, okay, that when you're differentiating stuff with respect to x, what you do is do it with respect to y, and then multiply it by dy by dx. And here's why this kind of makes sense. Here's why this kind of makes sense. So, if you think about it, now this is not what actually happens, but conceptually you can think about canceling this guy with this guy here. So on the right hand side you get d by dx of stuff. On the left hand side you get d by dx of stuff. So then it looks like saying that, hey, this looks totally legit. It looks totally legit. Because I have the right hand side is looking like the left hand side. So it's totally a legal way of doing things. Okay? And what I'll do is I'll illustrate this rule using this example. Now you can do this example in two ways. You can do this implicitly or you can do it explicitly. Okay? Let's try and do it explicitly first. Which means that you're going to take this equation and make it explicit. Remember, explicit means that y is going to be isolated by itself. So what do you get? Would you be okay if I wrote it like this? Yeah? Does everybody see why I like to write it like that? Because then I can use the, exactly, and using the, fantastic, good job girl, using the power rule. So what do I get if I differentiate this? Which is the same thing as negative 1 over x squared. This was the old-fashioned way, right? This is the old-fashioned way. No, I'm not using the implicit rule. I rewrote this equation into an explicit form and then I differentiate it. Okay? Now I'm going to use this implicit differentiation rule. So let me change colors here, okay? Does everybody see that this is a product? X times y. It's a product. So I'm going to use the product rule. To do the product rule, I'm going to keep y constant and differentiate x. What do I get? Y. Then I'm going to keep x constant and differentiate y. Remember, you're differentiating with respect to x. So it becomes dy by dx. You guys with me on this? Okay. Do you understand the product rule, right? I kept y, I differentiated x. Now I'm going to keep x, which is right there, and I'm going to differentiate y. Well, what's differentiating y? dy by dx. That's what it means to differentiate y. Okay, dy by dx is differentiating with respect to x. And then what's the derivative on the right hand side? What's the derivative of a constant? 0. What do I want to do? What do you think I should do now? Plug what in where? Exactly. Move what where? So leave this alone like this, you mean? And move the y over? So it becomes negative y. Now what? Nice, good job. Do I know what y is equal to from this equation here? 1 over x. So doesn't this become negative 1 over x squared? Because y is 1 over x. Isn't this the same answer that we got the old-fashioned